Good day, I'm Maile Matsiva. Welcome back to our channel. Today we continue with our SWK 210, which is Strength of Material. We're looking at chapter 1, and today we're looking at problem 1.6. It says here, there's a figure there. It says here, two steel plates are to be held together by means of a 16mm diameter high-strength steel bolt fitting snugly inside cylindrical brass spacers. Knowing that the average normal stress must not exceed 200 megapascals in the bolts and 130 megapascals in the spacers, determine the outer diameter of the spacers that yields the most economical and safe design. So I just want to explain a few things here. I just want to read just a portion of this. This is actually what happens. This is a bolt. It's actually the bolt. It's like this. It's a bolt. This is a bolt and then a bolt, right? And it has a screw here. This is actually a screw, the screw of the bolt, right? Sorry. My drawing might not be so perfect, but I just want to illustrate what's actually happening there. So yeah, this is actually what's happening here. If you see this part, this is one thing. This, well, rather, let me say this is actually the bolt. This is the bolt here, right? And this is the screw that ties the bolt, isn't it? Now this here is actually a spacer. Let me draw it here. It's I'll just draw just some not I'll just see how to draw it. It's actually like this. So I drew it in part. Of course it's mounted to this, so it's yeah, well, this is actually how it is, but it can either how do I draw this though? Like I'm trying to illustrate the fact that this bolt is actually entered here, and this is actually this is actually like this. It's more cylindrical. It's just that I had to draw it like this just to show you. So the bolt has entered here, and this is the screw that is actually tied at the side, and this is actually what's happening here and also here. So now they are saying that knowing that the average normal stress must not exceed 200 megapascals in the bolt, which means the average normal stress must not exceed 200 megapascals in the bolt, and also 130 also it must not exceed 130 megapascals in the spacers. This is actually the spacer. So now with that knowledge, with that information in place, so determine the outer diameter of the spacers that yield the most economical and safe design. Now they want to know the outer diameter. This is actually the outer diameter, DO of the spacers, right? I'm just going to be illustrating throughout the question as DO of the spacers, and there's also the inside diameter, which is DI, right, of the spacer. So there are two diameters there. So we know we know here that we're going to need to calculate the outside diameter of the spacers, and we're going to calculate that based on the information that we are given, that the average normal stress of the bolt must not exceed 200 megapascals, and also the average normal stress of the actual spacer must not exceed 130 megapascals. And lastly, another thing that I need to explain here is they are telling us that or rather not really telling us, so the bolt is actually experiencing some tensile stress and the spacer is experiencing some compressive stress. This is because if you take the bolt and you put it here, when you tie it, right, when you tie it, by default the bolt is kind of squeezing in, because you know the screw is actually, when the screw moves, the space between the bolt and the screw gets a little bit smaller, and as such, if you have the spacer here, it gets squashed. So the spacer is experiencing a compressive stress, and at the same time, because the spacer is squashed and it's also steel, but it's also pushing the bolt and the bolt and the screw apart, and as such the bolt is experiencing a tensile stress. So that is just something I needed to highlight there. So now with that said, we need to calculate this diameter. Now for us to calculate diameter, it's always important to start somewhere. Let's start with the stresses of both the bolt and the spacer. So we know that the normal stress of the bolt is generally P, or the force of the bolt, all over the cross-sectional area of the bolt. That is something very much straightforward that we know, and we can just say therefore the stress of the bolt is equals to the P, which is of the bolt all over the area of the bolt. We know is pi over 4 multiplied by the diameter of the bolt squared. So this is basically the area of the bolt, or rather the cross-sectional area of the bolt. And with that said, we can leave it like this, or we can actually do some rearrangement to make sure that we make the bolt the subject of the formula. And the reason of that is that in this case we won't really have the what's called, like, we will need equilibrium, and then we in this case it won't be so easy, it won't really be possible to get the equilibrium of the stresses, but we can actually get the equilibrium of the forces, because Newton's third law says for every action there's an equal but opposite reaction. So which means that if you put the bolt here and you squeeze it, the bolt, the power or the force that the bolt is using to squash or to squeeze the spacer is exactly the same force that the spacer is using to try to push the bolt apart from the screw, or rather to try to withhold the bolt from squeezing it. So which means that we can actually get the forces. With that said, we can just say P of the bolt, and we can just, it's easy, you can just multiply everything by the denominator, so we can just get it's equals to pi over 4 d of the bolt squared multiplied by the stress of the bolt. So let me name this equation 1. So now with that said, we need to go to equation 2, rather we need to go to the spacer. You can call it equation 2 or the spacer, it doesn't really matter. So now we know that the stress of the spacer is equals to the force of the spacer all over the cross-sectional area of the spacer. Now in that same light, we say the force of the spacer all over. Now the area, the cross-sectional area of the spacer is actually, the spacer is actually hollow. It's cylindrical, but it's hollow because it's the bolt has come inside of it, which means there's actually a gap here. So it has two diameters. So we can just simply say pi over 4, the diameter of the outside diameter of the, let me say, spacer squared, right, minus the internal diameter of the spacer squared. I hope it's easy for everybody to follow. Now with that said, the force of the spacer is equals to, do the same thing, multiply everything else by the denominator. So we have pi over 4, the diameter, the outside diameter of the spacer squared, minus the inside diameter of the spacer squared, right? And then now we multiply by the stress of the spacer. Yeah, this is because this continues to be here. So this is what I did here, simple arithmetic, some high school arithmetic, I think grade 10 or grade 8, 9, 10, somewhere there. So I multiplied this by this, and then in this side it cancelled, on this side it multiplied by this. So now we have our second equation. So now when we have the second equation, as we move forward, what we need now is to, we can just simply say equate equation 1 and 2, or you can even say let, or let me say, or let PB is equals to PS. It doesn't really matter. Now with that said, if we're gonna be doing that, so we're just going to be taking this and equate it to this, we'll say therefore pi over 4 multiplied by diameter of the bolt squared multiplied by the stress of the bolt is equals to, this here is pi over 4 into the outside diameter of the spacer squared minus the inside diameter of the spacer squared multiplied by the stress of the spacer. So now it puts us here. Now with this said, you can just do a simple quite a little bit of some simplification. And another thing, okay, before I'll get there, let me just do some, you can see this pi over 4, pi over 4, so we can just say, therefore, this ones can just fall off when we say this squared, the diameter of the bolt squared, multiplied by the stress of the bolt is equals to, well, this is cancelled, right? Is equals to the stress of the spacer into the diameter, the outside diameter of the spacer squared minus the inside diameter of the spacer squared. Now this is what we have. Now there's another thing, and another important issue here about this course is the wording, like the wording, the word they use. They say here that the bolt is fitting snugly inside the cylindrical brass spacers. That tells us that they are basically saying this bolt here fits exactly here, and that tells us that the diameter of the bolt is equal to the internal diameter of the spacer. This is because of the wording, and that's something very much important. Now with that said, we can just say since the diameter of the bolt is equal to the internal diameter of the spacer, right? Then we can just conclude and say, okay, let me how do I put it? I can leave it like that, or just say substitute. Okay, I can just say substitute dis with db, right? That can also function very well, just so that it can be easily simplified. So, or I can just leave it and just say, therefore, let's rewrite this. We have db squared here, the diameter of the bolt squared multiplied by the stress of the bolt is equals to the stress of the spacer into the diameter, the outside diameter of the spacer squared minus, remember now, the internal diameter of the spacer. I'm gonna replace it with the diameter of the bolt because they are telling me that the bolt fits snugly, and I explained that that means the internal diameter of the bolt is equals to, rather the diameter of the bolt is equals to the internal diameter of the spacer. Now with that said, I'm just gonna be putting that and say db squared, right? Now remember here what we want here, basically the question says determine the outer diameter of the spacer. Now with that said, we can simply then start fighting to make DOS as the subject of the formula, and with some simple and we can simply do is that we can actually divide by stress, or rather the stress of the spacer, right? And then take the dB at the other side. And with that said, we can just say, or let me just do it slowly. Let me just say DOS squared, right, is equals to dB squared plus the stress. So I'm saying this is equals to this, right? But for me to get this alone, I need to divide by the stress of the spacer, right? And after that, after I divide it, I'm left with DOS and DB. So which means if I move DB that side, it changes the sign. Now it becomes plus DB squared. So this here, like I said, guys, it's no longer strength of materials. Now it's mathematics. We are done with strength. So now we're going to be doing some simple mathematical arithmetics. And I'm convinced that it's going to be much easy for us to get, to conclude everything else. So we say, therefore, DOS is equals to, okay, let me say, DOS is equals to square root dBs stress B all over stress plus dB squared. So I basically removed the square and I say therefore DOS is equals to that square root. Now remember there's dBs here. Sorry, dB squared. What have I done here? Yeah, let me see. I made an error somewhere. So this is squared, right? Yeah, this is squared here, and if that is squared, then this is squared here, and if that is squared, then this is also squared here. And yeah, I fixed that, guys. Sorry about that. And this is also that squared there. Now with the when we get here, then remember there's actually dB squared and the dB squared. We can just take out the dB squared and then and make it subject of the formula. We can just say dB squared into, we are left with that all over that, right? Plus here we are left with 1, right? But we're not done. We can still do some more mathematics because we have squared here. We can just take this out. We can say therefore DO squared, DOS rather, is equals to DB, right? I took this squared out of, remember there's a square root. Mathematically I can actually take this dB and make it, it's no longer dB squared, is dB because I took it out of the square root, and then we are left with B stress of the bolt over stress of the spacer plus 1. Now when we get here, we can just do some substitutions. So we are told that we are actually told that the diameter of the bolt is 16 millimeters. So 16 millimeters is 0.016. Yeah, that's it, right? It's 0.016 meters, right? And then we go with the megapascals. We know the stress of the bolt must not exceed 200 megapascals. So we can just say it's 200 times 10 to the power 6, that is megapascals, right? All over 130 times 10 to the power 6 plus 1, right? So now when you get here, when you get here, then you can simply, use your calculator there, and it's gonna give you, I think it's 25 millimeters or something. I kind of forgot. Yeah, I think where I solved it, I left it here. I didn't really punch in the calculator, rather the calculator. But if you do it from here, I think it's something around 25 millimeters, is it? Yeah, I think it's 25 millimeters. Yeah, just verify that for me. But once you get here, everything else is sorted. And yeah, stay blessed, guys, and thank you guys for your time, and keep viewing, keep subscribing. And yeah, very soon I'm gonna be telling you more information about my tutoring company or my tutoring services. So we're gonna be having a very good time. And yeah, stay blessed, guys, and see you on our next episode. Also, don't forget to verify this, right? Or let me just do this. Put in a calculator here just to be sure, because some might be confused. Put in a calculator and that will give you the answer. Thank you guys. Stay blessed and I love you guys.